Hello, my name is Shivani. I am a new tutor here at Wyzant, and I'm here to help you with your physics problem regarding electric potential. So let's get started by reading the question. There's two charges, 6.9 nanocoulombs, and Q2 is 4.20 nanocoulombs. They're each located, it looks like, at 80 centimeters on the positive x-axis. Calculate the net electric potential by these charges, and these are the answer choices. So this is my setup. We have the origin, and then we have Q1 and Q2, which are both located at positive 80 centimeters. So the equation for electric potential, which I'm going to write as K Q over R. So K is our constant. It's 9 times 10 to the 9 newtons times meters squared over coulomb squared. And again, the potential has a units of volts. And then Q is the magnitude of the charge in coulombs. And R is the distance from the charge in meters. So as long as the charges have units of coulombs and the distance has a units of meters, the value of the potential that we calculate is in volts. So now the potential at the origin is the sum of the potentials exerted by Q1 and Q2. So P from Q1. Now, the charges are in nanocoulombs, so we need to convert them to coulombs. So 6.9 nanocoulombs is 6.9 times 10 to the negative 9 coulombs. And 4.20 nanocoulombs is 4.20 times 10 to the negative 9 coulombs. Since 1 coulomb has 10 to the, since 1 nanocoulomb is 10 to the negative 9 coulombs. So potential from Q1 is 9 times 10 to the 9 times 6.9 times 10 to the negative 9. And the radius, the distance from the origin, we have 80 centimeters here, but it has to be in meters. So 80 centimeters is equal to 0.80 meters, since 1 centimeter is 10 to the negative 2 meters. And I could go ahead and show that calculation real quick. So 80 centimeters times 1 meter for 10 to the negative 2 centimeters. Or wait, sorry. It's the other way around. It's 10 to the 2 centimeters. So 80 centimeters times 1 meter over 10 to the 2 centimeters. So that gives us 0.80 meters. I just wanted to show that real quick. Now going back to our problem, we would plug in 0.80 meters for R. So for the potential from Q1, let's plug this all into our calculator. So for Q1, the value of the potential is 77.625 volts. Now let's do the same for Q2. And if we plug all this into our calculator, let's see what we get. So we end up with 47.25 volts. So now the electric potential at the origin is going to be PQ1 plus PQ2. So I'm just going to do this on another board here. So PQ1 plus PQ2 would be equal to 77.625 plus 47.25. And that would be 124.875 volts. And we can round it up to 125 volts, since if you recall, that was actually one of the answer choices, was 125 volts. All right, so before we finalize it, let's just quickly check our work. I always like to check the work before I finalize an answer. So we have two charges, 6.9 and 4.2 nanocoulombs. They're both at 80 centimeters from the origin. So the total potential at the origin caused by these charges would be the sum of the potential of the two charges. So we have 9 times 10 to the 9 times 6.9 times 10 to the negative 9 divide by 0.80 plus the potential from 0.2, which is 9 times 10 to the 9 times 4.20 times 10 to the negative 9 over 0.80. And we end up with 124.875, just like we initially calculated. So our final answer is choice B. I don't know why I put B there. But yeah, that pretty much sums up the answer and the explanations. If you have any questions regarding my work, you can just leave a comment in the comment section. Thank you and have a wonderful day.